Hello everyone and welcome back. In the previous session, we already have seen the construction of LL1 parsing table. In this session, we are going to observe the LL1 parsing. So without any further ado, let's get to learning. Coming to the outcome of today's session, today we are going to observe an illustration of the entire LL1 parsing procedure. Now coming to LL1 parsing, we know the LL1 parser has got an organization like this. Now today we are going to take this particular grammar and feed it to the LL1 parser, and we will observe how to create the LL1 parsing table for that. And thereafter we will observe that for a particular input string, how the LL1 parser is going to produce the parse tree. Now in order to create the LL1 parsing table for this particular grammar, we need to find out the first and follow of all the non-terminals involved in this particular grammar. So let's begin with the first. Now we already know it's always a good idea to start with the last non-terminal listed in all the production rules. Now as you can see, B can be rewritten as small d or epsilon. So in the first of B, we are definitely going to have the terminal symbol d. And alongside this, since B can also generate epsilon, therefore we are going to include the epsilon in the first of B. Now similar to B, for the non-terminal A, in the first of A, we are going to include the symbols C, that is the small c or the terminal symbol C or epsilon. Now what about S? As you can observe, the production rule states S can be written as small a followed by capital A, capital B followed by small b. So basically in the first of S, we are going to include the terminal symbol A, that is small a. So these are the firsts of all the non-terminals involved in this grammar. Let's begin with the follow now. Now observe carefully, the non-terminal symbol S doesn't really appear in any of the right-hand side of any of the production rules. Therefore, the start symbol is only going to have the dollar symbol in the follow set. Now what about A? As you can observe, A is being followed by the non-terminal symbol capital B, and the first of B includes the terminal symbol D and epsilon. So definitely for the follow of A, it is going to include the terminal symbol D. Now B can also generate epsilon. So in case B generates epsilon, in that case the non-terminal A will be followed by the terminal symbol B. Therefore, in the follow of A, alongside the terminal symbol D, we are also going to have the terminal B. Now what about the non-terminal B? As you can see, the non-terminal capital B is being followed by the terminal symbol small b. Therefore, in the follow of B, we are going to have only the terminal symbol small b. So these are all the firsts and follows of all the non-terminal symbols involved in this particular grammar. Let's now construct the LL1 parsing table. So these are all the non-terminals S, A and B. Let's now find out the terminals involved in this grammar. So the terminal symbols are A, B, C, D, and alongside all these, we are also going to include the symbol dollar as a terminal symbol. So let's begin with the non-terminal symbol S. Now in the first of S, we have the terminal symbol A. So the production rule S can be written as small a followed by capital A, capital B followed by small c. We are going to enlist this particular production rule in the column of A. Now since S doesn't really produce epsilon, therefore we don't really need to worry about the follow set. Let's proceed to the next one, that is A. Now in the first of A, we have got the terminal symbol C. So the production rule A can be written as C is going to be placed in the column of C for the row A. Now A has got another production rule, A can be written as epsilon. So basically A can generate epsilon. And since it can generate epsilon, therefore we need to consider the follow sets. And according to that rule, we are going to place the production rule A can be written as epsilon in the columns of D and B. Now let's move on to the next non-terminal, that is capital B. Now in the first of B, we have the terminal symbol D. Therefore, the production rule B can be written as small d is going to be placed in the column of D of the row B. Now B can also generate epsilon. Therefore, we need to consider the follow set. So the production rule B can be written as epsilon is going to be placed in the column of B. So now we have our entire LL1 parsing table. Let's now observe how the parse tree will be generated for this particular input string. Now the parsing will begin from the start symbol, which in this case is this S. So we are going to push this particular non-terminal into the stack first. Now observe, S is actually being followed by the dollar symbol in this stack. And this is the reason why the follow set for the start symbol always includes the dollar symbol. Anyway, let's proceed with the parsing. As you can observe, in the top of the stack, we have the non-terminal S. And in the input buffer, the lookahead says we have got the terminal A. Now looking at the LL1 parsing table, observe, S on seeing A is going to use this particular production rule. So basically we are going to pop this S, that is this non-terminal, and whenever we pop something, it specifies that the parse tree is being constructed. Now in the stack, after we pop S, we are going to replace it with the right hand side of the production rule, that is this particular sentential form. Now the right hand side of the production rule is going to be stored into the stack in the reverse order. That is, we are going to store small b, then capital B, then A, then small a. Observe, we are maintaining the order. Now this basically means from S, we are trying to derive this particular tree. But we are yet to derive it. This is just the structure that we are going to derive. Now focus on the stack. In the top of stack, we have the terminal symbol A, and in the input buffer, we also have the terminal symbol A. So this is a match. And whenever it's a match, we are going to pop the symbol from the stack. And by popping it, we are specifying that this particular branch of the tree that S derives this A is being finalized now. Now since we have matched one terminal symbol from the stack, popping of it will signify that we increase our input buffer scanning. So now in the input buffer, the lookahead is saying the terminal symbol is small d. Now notice the stack. On the top of the stack, we have the non-terminal capital A. Now for the non-terminal A, if the parser sees the lookahead as D, then from the LL1 parsing table, it is going to choose this particular production rule, that is A can be rewritten as epsilon. So we are going to pop A from here now, and popping A will mean that we are finalizing this branch of the tree, that is S can derive capital A. Now after popping A, due to the production rule A can be rewritten as epsilon, the top of the stack will be replaced with epsilon. Now coming to epsilon, it actually means empty string. So we will pop it, and this will finalize the derivation A derives epsilon in the parse tree. Now once epsilon is popped, observe the stack, we have got the non-terminal capital B in the top of the stack. Now in the input buffer, we have the terminal symbol D. So coming to B, seeing the terminal symbol D in the input buffer, the LL1 parser is supposed to choose this particular production rule. Therefore, B will be popped, and by popping B, we are finalizing that this branch of the tree that S can derive B is getting finalized. Now once B is popped, it will be replaced by the terminal symbol D now. Now as you can see, in the top of stack we have D, and also in the input buffer we have D. So this is a match. And since it is a match, we are going to pop D, which will finalize the derivation B can derive D. Now since the terminals in the top of the stack and in the input buffer match, therefore we are going to increase the scan. That is, now in the input buffer, the lookahead will move to the next terminal symbol, that is B. Now observe the top of the stack, it is having the terminal symbol B. So it is basically a match, isn't it? So we are going to pop B, which will specify that this particular branch of S that S can derive small b is finalized. Now since the terminals match, therefore we are going to increase our input buffer's lookahead. So now the lookahead will get to the symbol $. Notice the top of the stack. It is also having $, so it is a match, isn't it? Now in an LL1 parsing, as you have observed, whenever we match any terminals from the input buffer and in the stack, we practically construct the parse tree. And finally, when the input buffer symbol $, matches the top of the stack $, it means the parsing is successful. And if you observe the parse tree, that also yields the same input, A followed by small d followed by small b. It was our input, right? So this is how the entire LL1 parsing takes place. Do remember, whenever we replace any non-terminal in the stack with its right-hand side, in that case, all those elements in the right-hand side will be pushed in the stack in reverse order. And also, the lookahead in the input buffer will only move forward whenever we match a particular terminal. And finally, when the symbol in the input buffer $, matches the $ symbol in the stack, that will signify the successful parsing. And one more thing to remember, the grammars which are good for LL1 parsing are also known as LL1 grammars. Now we can find out whether a context-free grammar is LL1 grammar or not once we construct the LL1 parsing table for that particular grammar. Now how is so? Observe, for every non-terminal, considering a terminal symbol, we only have a single production rule, isn't it? As you can see, it's the same case for all the non-terminals. So, if for a particular terminal, there exists more than one production rule involving a non-terminal, in that case, the predictive parser won't be able to predict what production rule to use, and thus, that particular grammar will not be an LL1 grammar. And since for this particular grammar, the LL1 parsing table that we constructed contains only single production rules for all the non-terminals, that means this grammar is LL1 grammar. And that is the sole reason why for this particular input string, the LL1 parser could successfully parse the parse tree. So in this session, we went through an illustration of the LL1 parsing procedure. Alright people, that will be all for this session. In the upcoming sessions, we are going to observe some grammars and determine whether they are LL1 grammar or not. So I hope to see you in the next ones. Thank you all for watching.